Hello, I'm Tanel Jevstignejev from Altacom, representing Utimaco. We operate in Finland and 3 Baltic countries. And for past 8 years, I've been working closely with managed IT service providers to help them grow their business and be more efficient. And on the other side, been closely working with government and private organizations to meet the regulatory requirements and needs. Now, when talking about Altacom a little bit, then we are probably not your average distributor in a way that we actually work really closely with communities. We have created MSP community for managed service providers in the Baltics and Finland, where they can do networking and share knowledge and expertise with each other. We also work with fintechs, enable them to integrate with SEPA payments, utilizing the Lithuania Central Bank Central Link framework to make instant payments, which literally mean that the payments will be transferred within seconds instead of taking days now than it used to be some time ago already. And also we've been involved in different electronic ID deployments across our region. So in a sense, we have had our small part of securing the digital society. And creating the trust there. And talking about trust, then that's a necessity in a global economy and digital societies nowadays, reliant on ever-growing connectivity, data use, and use of new innovative technologies. And to be really trustworthy, technology needs to be secure. Enabling the connected systems to be ensuring the integrity, confidentiality, and availability in a responsible way. While trust is such a fundamental building block of our society, creating digital trust has become a major challenge in our modern world, because digital technology extends across almost all aspects of our lives and across all segments of public and private institutions. How we can then create this trust in digital society, and usually this is through technology, and the key part of it is encryption, public key infrastructure, coupled with certificates, which make this create this chain of trust, which is then used in different systems and communications. And in Estonia, XRoad has really played a major part of securing and bringing the nation to the next level and helping it to become one of the leaders in digital societies. So when we talk about electronic IDs and the chain of trust, then it comes with compliance, regulation, and security standards. So in Europe, we have eIDAS, which is electronic identification and authentication trust services, which actually regulates electronic identification and trust services for electronic transactions in European single market. And then it's actually focusing on 2 aspects: interoperability, meaning that the member states are required to create common framework that will recognize electronic IDs from other member states and ensure its authenticity and security that makes easy to users to conduct businesses across borders. And secondly, the transparency. Also, eIDAS provides a clear, accessible list of trusted services that are available to engage in dialogue about best technologies and tools for securing digital signatures. So the eIDAS regulation provides environment really key aspects, such as digital identities, advanced and qualified signatures, advanced and qualified seals, also website authentication certificates, and so on. Then we had the security standards, such as FIPS, which is security levels, ensuring that that systems meet certain security levels. For example, enabling certain devices to be placed in, having the highest FIPS levels, to be placed in hostile environments where bad actors, adversaries can have physical access to these devices. Or common criteria, which actually certifies the entire processes of organization, starting from access, how the employees access buildings, how the manufacture is done, how the delivery processes are done, up to the security profiles. So when you talk about, then you can wonder that, what's the difference between advanced and qualified? So in a sense that advanced is just used in closed environments where trust is needed among entities who has a prior agreement before transaction. And qualified, this is pan-European, meaning that everyone can trust once it's sealed with qualified certificates. And looking into the future, then ADAS also will regulate, for example, digital archiving. Or remote signing, meaning that the keys that are being used for sealing or signing are not with the person or company anymore, but are stored on the service provider side. Or digital ledger, which relates to blockchain. And then maybe lastly, the European electronic digital identity wallet, which is designed to combine and where you can keep all your digital identities, such as passports, driver licenses, electronic ID cards, medical certificates, and so on, which then again gives users and companies larger and greater control of who gets access and how much to their actual data. Now, in order to become compliant and meet the regulations, a root of trust is required where you can store your certificates and seals. So HSM has to be used, and HSM is providing this root of trust to meet compliance requirements which are mandated by EIDAS. And since, for example, XRoad is using e-seals, then it's subject to EIDAS regulation, and that's why HSM is mandatory or strongly recommended when using XRoad. So and in a way, HSM is like a safe. So it stores your key in a secured environment. And the key point to take here is that once your key is found or compromised, you lose the trust. So a little bit about HSMs. If you're not familiar with these, then they come in different sizes and shapes. For example, from small chips on smart cards, which you might be using on daily basis with ID cards, with bank cards, and so on, to USB devices, PCI cards, LAN appliances, and nowadays in the cloud. So what are the key benefits? Why to use HSM, so hardware security modules, over regular software? Well, first of all, software has a bigger attack surface. Software has more vulnerabilities, more bugs to worry about, and HSM provides this secure, hardware secured environment against various attacks, such as memory attacks. While in software, if you're using keys, then they are being used unencrypted in RAM, which can be attacked access with modern techniques, or statistical attacks, which mean that how long it takes to generate the key, how much power it takes, and so on, or environmental attacks, meaning that protecting against freezing, overheating, and so on. Also, HSMs provide secure backups. or through random number generators, which are crucial to creating high-value keys because they create a really high entropy, which the keys are being generated from. And also HSMs prepare you for the future, enabling you or giving you the quantum crypto algorithms. So you can prepare once the crypto computers are powerful enough to decrypt the modern or hack the modern encryption methods. And also HSM provides you strong authentication, strong access capabilities, and audit logs. And then with HSMs, various APIs can be used. Some of them are public, such as PKCS11, which is open standard, or JCE, which is for Java applications, or CNG, which is for Microsoft. And HSM is nothing new, to be honest. It's been around for a really long time. Actually since the 70s. But nowadays, it's been used in pretty much everywhere in our everyday lives. For example, from the automobile industry, software updates to your cars, or over-the-air updates with modern cars. Even making sure the tires you buy are authentic, having small RFIDs there, just to make sure that there are no counterfeits, for example. Or when you talk about industry or Industry 4.0 and machine-to-machine communication, securing these communication channels. Or IoT field, where HSMs are used to together with key injections or device communications. We can talk about telecommunication, 4G, 5G networks, encrypt traffic, create encrypted networks, secure communications. We can talk about entertainment, where HSM are used to provide digital rights management. So when you are streaming movies, series, or music, then actually there's HSMs in play in the background. Or inside organizations internally, where you can use HSMs for internal certificate authorities, secure VPNs, secure accesses, offload HTTPS traffics, and so on. We can also see, and HSMs are widely used in banking, intra-banking communications, doing PIN translations when you are paying with credit cards, or excuse me, signing payment transactions. Coders use HSMs for code signing, or companies use it for access rights management. So actually HSMs are used a lot in the background. Now, when it comes to XRoad, then XRoad has built-in support for HSMs already, and it's happening over public API, PKCS11. And in Estonia, the XRoad servers are integrated with HSMs, usually on-premise, and also are used hosting services, where then the XRoad server and the HSM are hosted on the hosting provider side. And since most of the devices are LAN devices, then the communication between this XRoad server and HSM is happening over the network. This can be a LAN inside the organization, in the data center. This could be also over public internet using VPN, or secure channel, for example, secure messaging, which is native to the HSM. So the XRoad servers usually are deployed several ones. First of all, you have the cluster of XRoad servers when you talk about XRoad service providers in XRoad sense. And also they have development, testing XRoad servers, and production. And these all talk to HSM over at PKCS11, and inside the HSM, the keys are separated in logical ways, so none of these other environments can access each other's keys. And the HSMs also are deployed in clusters. to ensure high availability. And now, actually, what we have seen that the companies that are using HSMs have been started utilizing HSMs more. For example, to integrating HSM with their existing document registries where to sign and seal documents, or integrating with other systems within their environments, such as integrating root CAs or VPNs, just to increase the internal security of their environments. Now, a little bit about our experience with XRoad so far. So it all started back in 2016 when XRoad version 6 was released. On paper, everything is quite simple and easy, but the reality was a little bit different. We had a little bit rough start. For example, there was a transition time from XRoad version 5 to 6, and in between, the FIPS standard changed, meaning that the HSMs that are certified against old FIPS standard were fine, were working, but the newer ones, since the FIPS standard changed how the application talked to from the encryption side, talked to the HSMs, then the development of the improvement took some time, and there were some delays. Also, when it comes to tenders, for example, then there were some uncertainties about performances, what kind of devices are needed, and also like small compatibility issues from the HSM side. So, and over the years now, we have actually worked closely with government and private institutions, helping them to integrate the HSMs to their XRoad environments, and actually helping them to improve their internal IT to first of all, meet the regulatory requirements, and also to increase the internal IT security. And now cloud. Traditionally, the HSM market has been really, really conservative. Most of the devices have been deployed on premises, but now we have seen a bigger uptake. First of all, of hosted XRoad servers. In Estonia, for example, we have quite many local service providers hosting, first of all, XRoad servers and secondly, the HSMs there. But this can be decoupled, that you're actually running your XRoad server somewhere. And if there's a need that you need to be the sole owner of the keys and really keep them on premise, have key ceremonies and etc., then you can have like this hybrid model. But what we can really see that in the close future, when the service providers start utilizing the next generation 3 HSMs, such as Utimakos uTrust Anchor platform, where you can run different HSMs for different certifications, such as FIPS, common criteria, and so on, PCI DSS, on the same hardware, then we can see that there will be a much higher uptake from the and much greater offering from the HSM as a service side. And now, maybe the most currently the limiting factor why it hasn't taken off the hosted XRoad and the HSM as a service is because of regulators and auditors. They really haven't set the clear guides. What are the requirements needed to deploy and use these HSM devices in the cloud? But once these things have been cleared out, then we will definitely see the adoption rates to accelerate. Thank you for listening. And now I'm more than welcome to, or more than happy to answer any questions you can have.
Tanel, hello. And I'm more than happy also to join you back on stage also because you're the first in-person guest and speaker of the day. Otherwise, I mean, a community event that is essentially like a one-man show would not be that good. But let's get right away into the questions because from the audience we got some interesting questions like that. Try to delve deeper into the topic. Apart from what you have explained, which was like a very interesting and in-depth, extensive introduction and presentation. So, for example, someone is asking. How long would it take to integrate like HSM? Like, is there a need to develop also anything else, let's say, in parallel with it to make it work?
It's really simple to actually start using or integrating HSMs with XRoad. So actually what it takes is just you deploy your XRoad server. Of course, you need the HSM. You deploy the library, configure the APIs, configs, you generate your keys on the HSMs, create certificate request, send it to root CA, which gets signed, and then once it's imported back to the HSM, you are good to go. Another thing is that besides XRoad, which already has built-in capabilities and support for HSMs, when we talk about your other systems, then this might require additional resources and developer time.
Okay, but like we said, it's very simple. But you said like a long list of tasks. But actually, in reality, it takes like it's simpler.
Deploying it.
It's easier done than said.
For me, 15 minutes.
It's easier done than said, so we can say.
Yes,
okay, and then also we got another question. One, for example, is about costs. Actually, I'm covering like I'm picking the very essential ones, let's say, at the moment, so that we can get a bit more of an overview, and then like maybe we can go deeper in some other HSM specific questions. So, what are the costs, let's say, of implementing it in general?
Well, it all depends on the requirements, the performance requirements you have. You can start from the really lowest one. Usually in deployments, you can use the USB HSMs, which have quite low transactions per second performance. And you can go up to PCI cards and LAN appliances, which can cost you tens of thousands of euros. So there are various aspects, and also when it comes to regulations, then if you need to meet FIPS or common criteria, this can cause also, can increase or have different pricing.
And there's some other questions instead that I see that are not related to indeed like how long does it take or like how much would it cost. There's something, for example, on what happens. No, this I think it's better to ask this one first and then the other one. So how fast or powerful should HSM be for XRoad? Is there like any, I don't know, rule of thumb, let's say, sort of thing?
As I said, there was a lot of confusion in the beginning as well, and not knowing exactly and how many signings you are doing per second, to be honest, because some of the, it could be really high. So it needs to be measured and analyzed. There are some ways how you can do it. I haven't checked the latest XRoad versions, but maybe the really latest ones have also already capabilities of showing you how many transactions when it comes to HSM you are doing. But there are measures also from the logging side, how you can do it. And also HSMs nowadays have capabilities to show you how many transactions you're doing. And actually, this is like defining how many transactions and also the cost.
Maybe this is something that with the with XRoad 7 and the topic of XRoad metrics, I'm not sure. Maybe I might be saying something that is not connected, but maybe this is something where it already can give you like more insight into answering, let's say, this question. And by you, I mean, of course, like the customers and anyone interested in it. When it comes again, like still on to HSM, what happens if HSM goes down? Like, does XRoad like keep working normally and like fully operational for clients, or I don't know, there is a major crisis, let's say?
Luckily, first of all, you need to deploy it in a cluster. This also mitigates certain risks already. But if you have a major issue, I don't know, data center bursts down, which actually has happened once. So this can cause actually, yes, disruption unless, of course, if you are keeping the HSMs in one data center, this is like a major mistake anyways. But indeed, then the XRoad server can't sign the messages anymore, and it's in that sense, the service providers can't provide the services anymore.
Tanel, I will ask you one last question, very briefly, telegraphic essentially. Is there anything, let's say, that comes up to your mind if I ask you what were the biggest challenges or successes as well, like in implementing HSM for the XRoad community?
Biggest challenge is that the know-how of HSMs, especially amongst the developers, is quite low. So that's why we have worked closely and constantly working with developers to up the knowledge of how they can utilize and use HSMs. And biggest success, I think, is the when we see that what benefits our customers and partners are getting using HSMs, and how the trust levels are increasing, and success when they actually meet the regulatory requirements, which can be quite long, take quite long to meet.
Perfect. Tanel, this was our last question for today. We run out of time, but thanks a lot for joining us on the stage.